Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from Vinod Gupta School of Management, IIT Kharagpur, who will be taking this course for you. We are in module 3 now and we are discussing segmentation, targeting and positioning. So in the last video, we have discussed at length about what is segmentation, how to do it, what is targeting and what are the utility of targeting and how to position your product when you target a market. So here in this presentation, we will go ahead from whatever we have done in the last class. So first things that we will discuss about the steps of segmentation, targeting and positioning, and these are the 5 steps that are there. Behavior of consumer, and we do it through factor analysis, that is the first step. And then we do some, so and the factor analysis will have this kind of methods, this is the second step, this is cluster analysis step. So first we do factor analysis, and then why we do factor analysis, because there are lots of behavior that are involved, and sometimes those behavior has to be clubbed together so that some similar kind of behavior comes up. And the second step is cluster analysis, where based on the behavior of the customers, we try to find out which customers have similar kind of behavior and which customers do not have similar kind of behavior. And some of the classic methods that we apply to see that which kind of customers are coming close to each other and which type of customers are coming away from each other, we used. These are some of the methods like hierarchical clustering. WARDS is one of the part of hierarchical clustering method, and then there is another algorithm called k-mean algorithm, and there are model based algorithms as well. So second step is, so first step is to combine the behaviors to find out certain behavior, which is, for example, let's say price sensitivity. Price sensitivity is a behavior. Now, or probably sometimes the attitude of the customer towards the price. Now that can be seen as the behavior. You cannot actually ask all the customers what is their price sensitivity, but you can capture that, okay, this is a customer who only buys during the sales season, or he buys only when there is a particular some amount of offs are going on, or he always uses coupon. He cuts down coupon from newspapers and probably certain kind of coupon codes from different sources, and he spends time on that, finding out the sources of coupons and etc., and then he makes the purchase. Or he is not very happy to give let's say delivery charges in an e-commerce setup. He actually looks for options how to get away with the delivery charges. Now all of this behavior sometimes are related to a similar pattern of that particular consumer or similar attitude of that particular consumer, which is expressed in their behavior, which is, let's say, price sensitivity. In the other case, there can be, let's say, brand awareness. So a guy who only purchases major brands and who search for those brands, or who generally, even when the sales promotion of a non-branded product is going on or some other brand is going on, he will be loyal to that particular brand. So all of these things might come together as some single behavior as well. So there can be so many behaviors. A consumer makes so many behaviors in a retail store or in an e-commerce setup or different places. So we have to do first factor analysis, and we will discuss about that in a different part of the course, how to combine them and create certain meaningful characteristics of the customer. Now after we found out meaningful characteristics of those customers, we try to club those customers based on whether the meaningful characteristics are matching with each other or not, or if they match with each other, if customer A and customer B have similar meaningful characteristics, then they will be close to each other and they will be kept in the same bucket. And if this one set of customers, one bucket of customers are very away from another bucket of customers, then that is a good segmentation. That is something that we try to achieve. And the methods are hierarchical clustering, WARDS method, k-means, and there are other methods also, and a combination of them. So once you have created, now you remember that we have not talked about demographics. We have created all these clusters based on similar characteristics, which is behavioral characteristics. So we are not talking about demographics now, but you have to, once you created 2 segments, 3 segments, you have to name them. You have to name what that segment is. So let's say I found out there are certain people who are, let's say, price aware or price conscious, and then there are certain people who are like some other kind of behavior comes up. Now, who are they? What is this person? If a new customer comes in my retail store, how will I identify that whether this guy is segment A or segment B or segment C? So, for that we have to name the segments. So, for that we use something called defining the segments, that is the third step. Defining the segments, which is the third step, and then rather than defining, we actually try to find out how I can predict the segments. And generally we use methods such as let us say we use methods such as LDA, linear discriminant analysis, and there is a method called multinomial regression. So, at this moment, if you are with me, we will be discussing various methods, but you can go pause the video and probably search, and I will share certain links also. You will be finding it in the description or additional materials, where certain links will be given, where you can read about what factor analysis in general is, what linear discriminant analysis in general is, or what multinomial regression is. So, these are the kinds of topics which will be covered in a business analytics kind of course. So, I am not covering the nitty-gritty of the topics, what these things are, what is the algorithm, what are the findings and etc. But the part that we will be needing in our analysis, we will cover that. So, now given that what we will do, LDA and multinomial regression is nothing but trying to predict the segment of a customer based on certain demographics. So, this is the first part where demographics comes in. When you are trying to target, when you are trying to create a profile, create a name, create an identity of a particular segment, you are creating a human being's how the human being will look like. That is when you are trying to create a segment, and that is where the demographics comes in. So, what you do? You use age, gender, income, probably domicile, and various other places, various other things as your x variable, as your independent variable, and y variable is a categorical variable, which is like, it can be two categories, segment A and segment B. For that you can directly use logistic regression, binomial logistic regression. If there are more number of segments, segment A, B, C, D, we use something called multinomial logistic regression. Multinomial means there are multiple names, binomial means there are two names. So, we use multinomial logistic regression, and we can also use linear discriminant analysis, which is another method by which we can probably predict that whether a customer will be in segment A and segment B or segment C based on the demographic factors. Now, based on that, I will create my product features and etc., and I will target certain market rather than targeting all the customers. So, this is something that is important. So, here in the today's class, what we will do is, we will not do the factor analysis part. Let us say we will have some data points, and based on that we will create segments, and using those segments we will also try to target those segments using the multinomial regression method. So, I will also give certain inputs or certain information about how to, on the same data set, how to use LDA, linear discriminant analysis, and what is the meaning of that in a different class. So, today we will talk about customer segmentation. So, these are the three steps that I talked about, the four steps: hierarchical clustering, one of them is Ward's method, and K-mean and model based. So, we will majorly focus on the first three, hierarchical, Ward's method and K-mean. So, hierarchical clustering looks like this. So, let us say you have 5 people A, B, C, D, E, and you start from below. So, at the bottom, if you see that A, B, C, D, E, everybody A, B, C, D, E are all separate. So, all the 5 people are in 5 separate segments. Then what is my job? My job is join them to reduce the number of segments, and to join them to put them in a same segment. So, I find out, let us say A and B are very close. So, I join A and B, and in step 2 I have 4 segments instead of 5. A, B gets joined and C, D, E. Now, for further analysis I have to find the distance of C, D, E with the joint A, B as a segment rather than A individually or B individually. Okay. So, next I see probably CD are the guys who should be joined. So, I join CD. So, in the third step I have 3 segments, and then again I join CD and E, and then I join ABCD. So, I slowly go on joining. So, if I keep on joining, the maximum possible number of segments is all 5, where each of segment consists only one customer. So, all 5 has only one customer each. So, that is the maximum possible number of segments. What is the minimum possible number of segments? Yes, everybody is in the same segment. So, there is only one segment available. So, you can do many things. You can either start from the bottom and go to the top, that we call as agglomerative clustering, and I can also do the opposite one. I can start from the top and go to the bottom, which we call as divisive clustering. Both of them is hierarchical clustering, because they are creating a hierarchy of that. And how to do that? So, there are several methods of finding out the distance between 2 groups or 2 people and etc. So, let us say A, B, C, D, E, F, G, I have in this case 7 customers, and I have created 2 major variable, which is brand awareness and price sensitivity, and these are the scores given for brand awareness and price sensitivity. So, what happens is that I try to find out Euclidean distance between person A and person B. So, what is an Euclidean distance? So, the Euclidean distance formula will be, let us say, if A has 5 brand awareness and price sensitivity, has 5 and 7, and for B it is, let us say, 3 and 4. So, the distance between A and B is 5 minus 3 square plus 7 minus 4 square, and then square root of that. That is an Euclidean distance. So, we can try to find out an Euclidean distance. So, what is the Euclidean distances formula? The Euclidean distances formula is something like this. So, the formula is like this, that if A has x1, x2 up to xk number of characteristics. So, person 1 rather than A, and person 2 has, so x11, x21, xk1 number of characteristics, and person 2 has x12, x22, xk2 number of characteristics. Then what is the person I? Ith person has x1i, x2i, xki number of characteristics. So, let us say there are 2 persons I and j. The distance between I and j is basically xmi minus xmj square of that. Now, m varies from 1 to k, and then I take a square root. So, that can be the formula of the Euclidean distance. So, each of the 2 same characteristics you take it up. Let us say brand awareness of A, brand awareness of B, you take it up, find out the distance, square it up. Then again you find out price sensitivity, A come, it is of A and it is of B, you do a subtraction and square it up. And then let us say something else, let us say brand loyalty of A, brand loyalty of B, subtract it and square it up, and then you join them, add them up and take a square root. So, that is how Euclidean distance is calculated. So, once we calculate the Euclidean distance, we can calculate actually 7C2 number of Euclidean distance. So, each of the guys will have a Euclidean distance with each of the people. So, that is there. And then what we do is see the diagonal elements are all 0 and it is only a triangular matrix, that means nothing above the top. Why? Because whatever is above the top, above the diagonal is actually same to whatever is below the diagonal. So, if the distance between A and B is 3, the distance between B and A is also 3. So, that is why we only focus on any one part of the whole matrix. Now, you see which two guys are of least distance in this particular in this particular thing in the matrix that you can see here, which one has the least distance. So, you can see that the least distance is coming up for C and E and for B and C. So, C is the person who has the least distance with both B and E. So, if that is the case, then what will you do? So, if that is the case, then you can either join B and C or can join C and E. So, any two guys you can join. So, I randomly started, I started with joining B and C. Now, BC becomes one single segment. Now, there are different ways to find out how I can find out the distance from B and C to A, B and C to D, B and C to E and so on. So, which one? So, that is how the single linkage, complete linkage, average linkage and centroid linkage are different. So, you either find out the average of these two and then find out the distance of that from each of the observations, or you find out the centroid, or sometimes you find out the complete linkage. So, you take each of them's distance from. So, let us say BC is your segment, and in complete linkage you might find out B's distance with everybody, C's distance with everybody, and then take an average of that. So, there are different ways of calculating the distance. The easiest way of calculating the distance is actually taking the mean. So, I would suggest that if that is the case, if you have two guys, let us say B and C got joined. So, B is let us say 3, 2 and this guy is 1, 5, then BC when they got joined, the corresponding value becomes 2, which is the mean of 3, 1, 5 2 plus 2 7 by 2 3.5. So, you take this the mean real value, the average value of the two guys, and then you go ahead and try to find out the distances. So, you find out the distance, and then the next distance, which one is lowest? The lowest is BC with E. So, here I think they have not taken the average, they have taken the single linkage, which is the lowest distance. So, BC and E. So, BC and E is still 1.414. So, then if I join them, it becomes A. So, right now you have how many? 5 segments. Now, I have 5 segments, I can still join. Which one I will join? The lowest distance is A and D. So, I join A and D. Now, which one will I join? I will join either AD with AF or AD with BC. So, let us say I join AD with BC, because the size of the segment goes up by doing that. And then what will I join? I will join ABCDE with F. So, ABCDEF I join. So, I can keep on joining, and the last one will be everybody will be in the same segment. Now, this does not make any sense. If I keep everybody in separate segments, it does not make any sense, because I cannot create products for each of the people individually. And if I join them everybody in one segment, that also does not make sense, because as we discussed that not everybody likes lukewarm milk, lukewarm tea, some likes hot tea, some likes some people will like cold tea, and you have to find out which one will you target. You cannot actually create a lukewarm tea. So, putting all of them in one segment does not matter. So, then there has to be a point when I will stop. So, should I stop at 4 segments, 3 segments, 2 segments, where will I stop? That is something that is important. So, to do that, what we do is we plot. So, we see that when we started with from 6 clusters, from 7 to 6 we jumped. So, initially everybody was in separate clusters or segment. So, when we jumped from 7 to 6, the distance covered was 1.414. And then when we jumped from 6 to 5, we again distance covered was 1.414. The lowest distance was 1.414. And then when we covered from 5 to 4, the lowest distance, the distance covered was 2. From 4 to 3, it was 2.236. And from 3 to 2, it was also 2.236. So, if I plot that, generally what we find is a kink, Kink, what is kink means? It's a elbow like situation. What is this elbow like situation? Not always you will get such good looking elbow like situation. What is situation? That means that before that, if you actually further increase the number of segments, you do not get much information, but before that the information, extra information that you are getting is much higher. So, this you can assume as a measurement of information that you get, and this is where the elbow suggests that after that further breaking does not matter, does not make any sense. So, in this case we have found 5 as our classic segment. So, we can actually choose this 1 A, D, F and G are in separate segments and B, C, E are in same segment. So, that is how you do. Now, this is called hierarchical method. Here we have taken Euclidean distance as our measurement. Ward's method is agglomerative clustering. So, that means it is a hierarchical method and does not consider distance matrix. It does not consider distance matrix, not applicable for it is mostly applicable for quantitative variables and gives almost equal size clusters if there is no outlier. So, this is some of the characteristics of Ward's method, which is a special type of hierarchical clustering. So, here they actually measure the R square. So, how much is the, instead of distance they measure the R square and it checks that which one I will join that will actually improve the R square. And what is R square? R square is similar to what we measure in case of regression. If you remember the multiple R square, it is similar. So, if you see that the first one, the ESS is the error that is still left. So, Xijk, what is that thing? That thing is that, so for all the group, so for all people who are in ith group. So, ith group, so for all the people I find out the mean of that group and then divide it from that particular group's individual observations and then add them up. So, that is one part, which is the still error that is left, and TSS is when I had no segment, when I am only one segment, everybody was put in one segment, what was the situation. So, that is TSS, and R squared just nothing but it actually tries to find out whom I will put in which segment such that this R squared maximizes, that means TSS minus ESS by TSS maximizes. So, it is similar to, so TSS minus ESS is what, which is the part of the variance that has been explained. TSS is when there was no model, what was the error left. ESS was when there is some kind of clustering, what is the method error left. Now, that means TSS minus ESS is what, the numerator of this R square is what, the percentage or the amount of variance, not percentage, the amount of variance that has been explained by these clusters. So, if I want to see in percentage form, that by TSS gives me the percentage of the variance that has been explained by these clusters, and as R square goes high we join people. So, we try to find out whom to join such that the R square improves. So, that is something that is also a agglomerative clustering. That means, you start from all of them at separate segment and then you try to keep on joining, and here we measure, we actually plot this within sum of square as the measurement when we are measuring this. So, we also plot a scree plot, we call it a scree plot here. So, we also plot something like this, but the instead of distance covered we measure the within sum of square, that is Ward's method. And the third method that is very easy probably is something called K-means method. So, K-means method, so once you have decided through Ward's method or hierarchical clustering method that how much will be the how many segments you want and etc., you try to do something like, let us say you decided that I want to have 3 segments. Now, you will try to use K-means to give a better application. Sometimes K-means work better than the hierarchical clustering methods to find out that who will fall in which segment, whether the segment is stable enough or not. So, what they will do is, let us say I have 2 observations here also. So, in a 2-dimensional plane, you plot the points. So, that for example, let us say if you remember A was 3, 7. So, brand awareness and price sensitivity 3, 7. So, what we did here is A here you see A is this is 0. So, 1, 2, 3 and then this is 7. So, 3 comma 7 is A. Similarly, for every point I position them in the in this xy plane. If it is a multidimensional observation, if there was let us say instead of price awareness I had some other variables. So, the next method we will talk about is hierarchical clustering method. So, sometimes in comparison to Watt's method or in comparison to the hierarchical clustering method and Watt's method, sometimes the k-means method works better. So, the next topic is k-means method. What happens? Let us say through Watt's method and hierarchical clustering method, you decided that we should have through the scree plot, we decided that we should have 2 segments or 3 segments. So, what we do is then we put the individual values, like let us say here we had A, B, C, D, E, F, G, there were 7 observations and A was 3 comma 7. If you check, A was brand awareness 3 and I think price sensitivity as 7. So, you plot A, here you plot in x axis, you have plotted A as brand awareness in the x axis and in the y axis it is price sensitivity. If there were more number of variables, then you create a multi-dimensional space where if one axis is brand awareness, another axis is something else. So, sometimes we cannot visualize a multi-dimensional space for simplicity, that is why I have used a 2-dimensional plane. But in the multi-dimensional space, what you do is you actually put these points and then you close your eye and randomly put 2 points in the plane and see that how these 2 points, because you have 2 means, k means, that means 2 clusters will have 2 means. If you have more clusters, then more number of means, and how many clusters will come from the Watt's method or the hierarchical clustering method. So, you find out okay, I will have 3 or 4 clusters and you put those means, and whoever he has lesser Euclidean distance from the cluster mean, you just put that in that particular segment. So, that is the first job. So, what we do? I have positioned CC1 and CC2 2 means, and okay. So, A, B and C were close to CC1 than CC2. So, I put them in cluster 1 and the rest D, E, F, G are close to CC2 than CC1. So, I put them in cluster 2. But who says that this is something that then we have to check that how much these clusters are stable. So, I shift CC1 and CC2 a little bit, delta x in each of the lines, I would say each of my dimensions. So, I shift CC1 CC2 to new position CC1 dash and CC2 dash, and now I see that whether the number of segments and the I would say where the segment falls are same or not. And I see that all of a sudden this E guy has come to CC1 instead of CC2. So, that is something that I generally keep on repeating, and I check that where it will become stable. The place where it becomes stable, that is my final segmentation method. So, if I keep on doing that at some point of time I will reach stability, and that will be my segments. Now, a segment will be a good segment only when it is stable over all these 3 methods that we have discussed with. So, we will continue on this particular video in the next part, where we will do the coding with a data set and we will use these 3 methods of clustering, and then we will try to see that how targeting can be done. Thank you very much. I will see you in the next video.